forward divided difference here, guys, and we are given a graph here, and we have the equation here, and we look at the x, f of x here, the x here, and we have the x plus delta x, and the space between the x and delta x is our change in x, or our step size h. So we have f of x is the limit of f of x plus delta x minus f of x over delta x as the delta x approaches 0, or we can say that. And here in central divided difference, we have the graph here of x, we have the x minus delta x, we have the x in the middle, and that is our x plus delta x. Okay, so we have the rise over the 4, we have 2 delta x, 2h, so our rise is f of x plus delta x minus f of x minus delta x. And we can say that backward divided difference, we have here f of x, we have the rise and the fall, we have f of x minus f of x minus delta x, and we have there a delta x, we can say the x, okay, and that is the equation of rise. We have the limit of f of x plus delta x minus f of x over delta x as delta x approaches 0, or we can say that f prime x is approximately equal to f of x minus f of x minus delta x over our delta x. We have here our equations for FDD, CDD, and the BDD, and we are asked to solve this equation. We are given the xi and our step size h, so we have 1 and we have 0.3, so we get the functions, or we get our true value through assigning the xi to our equation. So at step size 0.3, we have our xi is 1, we have xi minus 1 0.7, and xi plus 1 1.3. We get their functions as we substitute the values of xi minus 1 and xi plus 1 and xi to our main equation, and we have negative 1.2784, negative 1.75, and negative 2.1576. After getting those, we just substitute those values to the equation as asked. For our FDD, we have and for our CDD, we just simply use the formula and plug in the required values to get our CDD, or the answer of our CDD rather, and we will have for our BDD, or backward divided difference. We also do the same as we did for the FDD and CDD, plug in the values to our main equation, and we will have negative 1.572. So we simply get at H3 our error, or our true error. So we have true value minus approximate value over true value to get the absolute value of that, and multiplied to 100. So for the FDD, we have 7.2%. Not bad, because that is relatively small. For our CDD, let's see what we got. And we have 1.2%. That is smaller than our FDD. And for the BDD, we have 4.8%. Still smaller than our FDD. So we can say that CDD is the most effective way in getting our true value because it's close.